90% of the problem and quite a few explanation that we deal with physics, we represent things by using free body diagram. What does that mean? Well, I have an example over here. A car being pulled. This is the situation. What are the forces acting on it? One is the gravity. Other is the normal force, which is pushing it up. Another is a person pulling it. And another is the force of friction. So all these forces are acting on the object. But if I want to represent this, see, I am able to draw this maybe in 10-15 seconds. But it's not that convenient for everyone, and maybe I won't get this good or this nice looking, I think it's decent looking diagram all the time. I'm not able to replicate it that way. So what they have done is they have told, okay, you can represent your situation using something called as free body diagram. So what it tells is you can represent an object, say using a box, a very simple thing that represents your car, or a person, or a book, or a ball. It can represent anything. Generally, we deal with boxes. You can use circles also. You can use other structure also. Not a big deal. But yes, generally it is customary to use a box. So what are the forces acting on it? Well, we have the gravitational force pulling it down. We have the normal force pushing it up. We have the person pulling it to the side, to the right, but not parallel to the horizontal. And we have the force of friction. Right? So this is a free body diagram of this particular situation. So let's look at the definition. A free body diagram are diagrams used to show the magnitude of strength and the direction of all the forces acting upon an object in a given situation. So this is your definition. A small note: the length of the arrow is proportional to the magnitude of the force. So you can see here normal and the gravitational force, they're of equal length. It means the forces are equal. Here the normal force is equal to the gravitational force. So indicating that the length indicates that their magnitude is the same. The direction of the arrow shows the direction that the force is acting on. So you can see over here the directions are up, down, left, right. Not exactly right, but you guys got this right. A slanted arrow, is it not? So the arrow indicates what direction we are talking about. This is a custom, it's not a rule. This set of points, the objects are drawn as a box generally. You can use circle also, not an issue. A force arrow are drawn from the center of the box. Again, you can represent it different way, but yes, it's a custom. So we begin the representation of the force from the center of the representation of the box outward in the direction that the force is acting. Okay, I hope that it makes sense, right? Label each force arrow according to the type: friction, normal, so on and so forth. It should make sense basically. One more example. I have an object that is under free fall. That is, someone has thrown it, or by chance it's happened to fall on its own because of some disturbance. So in this case, it's just falling on its own. No one has thrown it. So if I want to represent what is happening with this, first is it is being pulled by gravity. Next is, since it's just started to fall, the velocity is 0 at time is equal to 0. And then it accelerates downward. Don't think too much, it's okay. You don't need to understand why the acceleration is downward and all of this. I just want you guys to get introduced to free body diagram. And here I've used a circle rather than a box. So that is okay. Right? So this is a must that you have to know, and you have to write this down. We'll be using it in quite a few, quite a place, lot of place. So I would like you guys this to be in your book. So please pause and copy this off.